Greetings, humans. Linear functions is what we're going to be talking about here. We've got an example, a word problem. Ooh. Halloween noise. Okay, the average price of a movie ticket in the United States from 1980 to 2000 can be modeled by the function f of x is equal to 0.10x plus 2.75, where x is the number of years since 1980. So if x were 1, that'd be 1 year past 1980. X were 2, that'd be 1982, right? Okay, graph the function and identify its domain and range. Oh, look here, I found a graph. Okay, if we started at the point, well, if you look at this function, you've got y equals mx plus b. It's already in slope-intercept form, where this number 2.75 is your intercept. So if we travel to 2.75 on this graph, it's the point just below 3, right about there. Okay. And if we wanted to take a look at the slope is this number here, 0.10. That's really over 1. So every time you go up 10 cents, you move 1 year. So every year, it looks like it increases 10 cents. So it's going to be really hard to represent on this graph, but it just moves slightly above. This is at 2.95, and then not until 3 years after 1980 does it go above $3. And then it will continue in this with this trend, and you will graph a nice straight line. Notice it's not a true line because it ends here, and it will end at what point here? If it goes to 2000, that's 20 years past 1980, so it might keep going in the direction this way until you get to the x value of 20 and the y value of, I don't know. If x were 20, what would this mean for y? What would this mean for our function if x were 20? Well, if x were 20, you would be evaluating your function at 20. And it looks like 20 times 10 cents is $2 plus 2.75. So it looks like in the year 2000, or 20 years after 1980, the price of a movie was $4.75. So your range would be your lowest y value, or price of the movie, which in this case happens to be, what was it, $2.75? $2.75. And your highest value within this range is $4.75. Cool beans. So that's the range, and the domain would be from 0 all the way to 20, because we're just looking in the year range of 1980 to 2000. Okay, I've just shrank all that work, and let's find the value of x so that the f of x, or the value of our function, or the price of a movie, is $4.55. The value of x, so in what year and how many years after 1980 would the value of a movie be $4.55? Well, the value of a movie we know is equal to this stuff. And we also know the value of a movie to be equal to $4.55. So $4.55 is equal to the value of a movie. In what year? If we solve this equation, subtract 275 from each side, looks like 180 will be left over, equals 10 cents times x. Divide that 10 cents, and looking like a solid 18 years after 1980 is when the movie price will be $4.55. Does that make sense? Yes, Mr. Lemon. Okay, cool. Try this one on your own. Now, a couple of pointers I'll give you is the domain in range are limited. It's not a line that goes forever in both directions, because in this problem, it's talking about a year range from 1998 to 2003. So 98, 99, 2000, 2001, 2002, and 2003. So that's 6 years, including year 0 for x. When x equals 0, the year would be what? 1998. If x were 1, that means the year would be 1999, and so on. Okay, and it's very similar to our last problem, so good luck, and maybe we'll see what happens.